This is Hiren Desai again. This will be the continuation of the FC technology tutorial. In this tutorial, we'll just briefly talk about some of the physical characteristic of fiber channel network or fiber channel fabric. As you can see, I have switch 1, 2, and this switch is at a long distance. That's why we have sort of line here. This could be a long cable or going through some optical network, but we'll get into that. The typical FC speed when it was first founded around late 90s or so was 1 gig. Today, the common speed you will see is maybe 2 gig or 4 gig at the device level, and within the interlink switch you would probably see 8 gig, and as in some of the newer equipments which are coming in within last year or so are actually working on are doing 16 gig worth of link. But I would say at the device level you pretty much see about 4 gig worth of FC connectivity. And as we mentioned before, the T11 standard is actually working on 32 gig and 128 gig bandwidth. So that sort of say at what speed any of these networks are designed or runs at. Typically in this cabling here is an optical cabling. There are some copper connectivity, but they're not that popular. I would say most of the time from a device to a switch and switch to a switch would be an optical cable or optical connectivity. And one of the key thing about fiber channel fabric or fiber channel network, it provides you lossless network. What we mean by lossless is because of congestion, you will not have any frame drop. And how does fiber channel provides losslessness? So this is where you might have heard of a term called BB credit. What is a BB credit? So anytime, whenever a device logs in to a switch, or when a switch gets connected to a switch forming an E port, they negotiate how much receive buffer each endpoint has. So for example, in this example, when he did a fabric logging, he would say, I have four credit or 4 frame worth of buffers that I can receive. When he did that, he would say, I have 8, and typically 8. So this is where, and these are all link to link. So when he logs in, he would say, I have 4 worth of frame I can buffer. He would say, I have 8 worth of frame that I can buffer. Whenever this switch sends a frame, he will decrement his BB credit by 1. So now he has 7 frames that he can send. And so that way this link, he will continue to send frames until the credit becomes 0, and he will stop. Until this credit becomes 1, this link will not be used. It will be stopped. So that sort of guarantees that unless the receiver has a way to receive that, I cannot send anything. And when inside this switch or inside this device, when these frames which came in either got transmitted out here or got observed into the CPU, they will send what they call R-ready. R-ready means I'm freeing up this buffer to you. So when this device receives an R-ready, he will bump his counter to, instead of 1, he will bump it to 2. So again, he can send 2 frames. So as you can see, this is how the handshake or the flow control works within a connected devices. And I'm just showing you an example of a switch, but it doesn't have to be a switch. It can be end devices here also. But the important thing is BB credits or the flow control is link to link. Link this link or this link. So when the way a device will signal the sender saying I have a free buffer is by sending a ready or freeing up a buffer, and he will keep track of how many frames have I sent. So as you can see, this is how a flow control would work link to link. Earlier we talked about that I have a switch 2 and a switch 3 connected via some long distance, whether it's an optical switch here or I just have a long cable. This is where you would require maybe more buffer to buffer credit. Why then maybe I have a short cable? The reason is, remember I mentioned that when this switch sends the frame, he will send an already saying the buffer got freed up. But now if this is a long distance, there is a propagation delay where already is sent from here are absorbed by here. So until this already comes, you don't want this link to be idle. You want this link to be sending traffic and keep your throughput. So this is where having more BB credit or buffer to buffer credit will help in a long distance where you can keep filling up your pipe. So this is sort of the basic flow control or the losslessness in a fiber channel network. And when we cover the FCOE tutorial, you will see how Ethernet or FCOE actually guarantees flow control. But hence the original FC required lossless nature. We want the FCOE to be the same, and this is where some of the DCBX, you will see how they guarantee the flow control and lossless network. So that's kind of covers some of the basic fiber channel tutorial, including some of the physical characteristics. So thank you for watching the technology series. Hopefully you got a good overview of fiber channel and FCOE, and stay tuned for more technology presentation from us.